Please welcome to the stage ASEE President-elect Stephanie Adams.
Good morning, everyone. I hope you've had an enjoyable and productive conference so far. Have you? I've certainly had a good time. I'm happy to open today's plenary session, which will showcase numerous exemplary individuals. But before we get started with the awards, because this is, after all, Industry Day, I'd like to call to the stage a representative of an important corporate partner, Boeing, Mr. Howard Appelman. Howard is an Associate Technical Fellow at Boeing and also Chair of the ASEE Corporate Member Council. Howard will be presenting the Excellence in Engineering Education Collaboration Award. Howard.
Oh, thank you, Stephanie, and welcome everyone to Industry Day. This award, the Excellence in Engineering Education Collaboration Award, recognizes the corporate member council member companies that demonstrate best practices in their collaborative efforts with education to enhance engineering education. Companies who are nominated or recognized for their excellence and innovation in both of the following: collegiate level engineering and technology education, as well as pre-college, K-12, K-16 programs that inspire interest in science, technology, engineering, and math. Priority in judging for the award is given to programs and activities that extend beyond the general business and marketing objectives of member companies. For instance, a program involving active collaboration in educational activities involving a company and its employees with university faculty or students would be judged more favorably than a general marketing type program in support of a product or service targeting universities as its market. And more than one award can be given, but this year we have, among all of the nominations that were submitted, we have just one award, and the award winner of the 2019 Excellence in Engineering Collaboration Award is Chevron. And the award to Chevron is for demonstrating best practice in collaborative efforts with education to enhance engineering education through the Texas A&M Chevron Engineering Academies. Chevron will be presenting, talking more about their program and presenting details of their program at the 2020 Conference on Industry Education Collaboration at the CIEC. But here to accept the award today on behalf of Chevron is Cynthia Murphy-Ortega. Cynthia Murphy-Ortega is currently Manager of University Partnerships and Association Relations of the Chevron Corporation, and her organization manages Chevron's relationships with universities and professional societies and institutes throughout the world. Cynthia joined Chevron in 1991 and holds engineering, maintenance, and operations, financial, business planning, and process safety management positions with the refinery. In 1998, Cynthia moved to the Chevron Energy Technology Company and developed Chevron's technical competency development programs. In her role as organizational capability manager with the Process Analytical and Catalysis Department, she supported technical competency, engagement, management, staffing, and recruitment, then with business planning. And Cynthia participates on numerous boards with particular emphasis on engineering, education, and diversity and inclusion. And Cynthia holds a Bachelor of Science degree in Chemical Engineering from the University of California, Davis. So I'd like to ask Cynthia to come up to the stage, please, to receive the award on behalf of Chevron.
Thank you very much.
And here's a nice box that we got you for the award, too.
I don't want to drop it on the plane or something like that. Thank you.
All right, I think they'll let you through TSA with that. So thank you very much.
It is now my pleasure to introduce the National Outstanding Teaching Award. This award was established in 2003 by contributions from ASEE sections, members, and industrial partners. The award is designed to provide national recognition to an engineering or engineering technology educator for excellence in outstanding classroom performance, contributions to the scholarship of teaching, and participation in ASEE section meetings and local activities. Please join me as we honor Mark Budnick, the Paul H. Brandt Professor of Engineering at Valparaiso University.
Well, thank you. Thank you very much. It is indeed an honor to be recognized for your work, and even more so by your peers. And I love my job. I love working with students. And when I found out that I had the opportunity to actually talk to you for about 10 minutes today about engineering education, I knew exactly what I wanted to talk about, something that's really been part of my life in teaching for the last 7, 8 years, and I want to share it with you. And the topic I want to talk about today is incorporating play into our engineering classrooms. All right, so has anybody ever seen a classroom look like this? Has anybody ever had a classroom like this? When I talk to my sons about their high school classes, this is the picture they paint for me. Disconnected students, apparently dispassionate teachers, and a general malaise that set over everything. And any of the excitement or the passion that they may have had going back to that first day of kindergarten so many years ago, and the passion about excitement going to school has long been gone. But when I talk to my daughter about her years in grade school, she has a much different picture that she paints. This is what she tells me about. Kids playing and discovering and exploring together the world around them and seeing how things work and fully engaged and committed to taking their own role in their education. They're playing and learning. And I think this is one of the most important things that somehow we've forgotten as a society over the last 100 years, is that sometimes it's great to get people excited about learning again. And this is really what I've dedicated the last third of my engineering career to. Now, there's not really a great definition of what play is, but I'll try to give you what I've come up with over the years, is that over the last 3,000 years, throughout time and different cultures and places, all kids want to play. And essentially it just means that they're using their imagination to either act or interact with those around them without an adult leading them. And this kind of leads us back to this idea of a sage on the stage model of teaching versus the guide on the side model. You know, we don't want to be necessarily the adult just up in front telling the kids what to do. I'd rather be the adults on the side who has set up the play activities for my students to learn the lessons at hand that I need to get across, but letting them play and explore, fail, make mistakes, recover, and grow from those so they can actually get a better idea about what the world is around them and get excited and again, take some ownership in their own education. How did I get started with this? About 7 years ago, we started flipping a class in embedded microcontrollers. It's a required class for our junior electrical computer engineers. Preferred lessons, made videos. Students would work on all those back at home. Then they would come to class Monday, Wednesday, Friday, 3 days a week for 50 minutes, and we'd play engineering. We'd work on projects, we'd build things, they would make mistakes, they'd have to recover. It was fantastic. It was an amazing experience. The students loved it. They learned so much. It was so successful, we went to Texas Instruments, we got a small grant, we made it into a MOOC. As of last week, we have 24,000 students enrolled around 150 different countries. That really emboldened me to figure out how I could continue to embed more opportunities for play into my classes, because this is what my students were getting excited about. Here's some of the things we're doing now. On your right, as you're looking up there, there's a simulator from a Walt Disney World attraction called Tower of Terror. In this particular exercise, students are challenged to develop a control algorithm that manages 50 different inputs and 30 outputs to try to maximize the flow of guests through the attraction over a day's time. What the students find out very, very quickly is that it's hard. It's a big problem. And not only is it a big problem, there are solutions, but there are better solutions. On the bottom left-hand corner, there's an actual toy that I had back when I was a toddler called a Tupperware Shape-O ball. This is a great thing because now when I have my students, I have 20 of them, and I can break them out and we can talk about how we can. I see people nodding their heads. Yes, I actually bought these for my own kids when they were young. We talk about how, again, you can use these different tools and resources to learn about doing things better, because that's really what engineering is all about, trying to make things better than they were the day before. In the top left corner is a game called Superfection. It's not really well known, but it's a great tool that we use for technical documentation, where students have to learn how to write materials to teach someone else how to assemble the puzzle in a particular way. What the students find out very quickly is that it is nothing like writing a humanities or history paper. All right? Hilarity typically ensues. The tall building, elevator pitches are all the rage these days. Get your students out of the classroom, take them to a big building, make them practice the elevator pitches so they're going up and down the elevators. Next to that, I have 3 engineering students doing comedy improv. It's a program called The Dinner Party. In the back there, we have Superman. In the front, we have an orangutan, and then we have a French opera singer. And what we found was that over and over and over again, using these techniques, the students learned more about communication and teamwork, and it translated directly into better results in their projects. And the 2 images on the left and the right, you have a balloon animal and you have a cartoon drawing. And I use these periodically to break them out and show students that what we're looking at developing are processes to learn how do we do our work better. And that we can use these processes as engineers to have better outcomes and to even be more creative. Now, I'm not asking you to be childish. That's the last thing I need my professors to do. What I do want you to try to become, though, is to become more childlike, to rediscover the joy of learning on your own and encourage your students to do the same thing. If this is too much, go on a field trip. Get your students out of the classroom. Go find something nearby that you can do that's going to connect the dots for your students back to the lessons that they're learning. Simply getting outside the regular classroom is going to give students the idea that, hey, something's different about today. They'll perk up and they're going to listen. Tell your students stories. Collect a library of resources that you can practice and use over and over and over again. When I'm introducing control systems, we watch about a 10-minute clip from a Discovery Channel show on the Apollo 8 rocket launch that sent people to deep space for the first time. We look at a short story by Isaac Asimov called Run Around, where he introduces in the iRobot collection the 3 laws of robotics for the first time. And coincidentally, the failure of the 3 laws of robotics for the first time. And the students are then challenged to write a better 3 laws of robotics. In the bottom right-hand corner, from Amazing Stories, a 1950s pulp rag, is a short story called The Cold Equations. And students learn here that sometimes engineering problems are not going to have really pretty solutions. The next one over, The Martian, was made into a movie. It's a classic novel. It's becoming a classic novel that teaches students a lot about real-world engineering and how sometimes we simply have to keep working problems until we can find that solution that's going to be optimal. And then finally, there are countless examples of how engineering is used around the world to make people's lives better, to provide pure water or clean energy, or helping people walk or see or hear again for the very first time. Whatever you do, do it the best you can. And I go back to a book by Jim Collins called Good to Great. In it, he had 2 pieces of advice. Number 1, be humble. Be a servant leader. You're there for the students. That's what the classes and the laboratories are for. If we wanted to do this for ourselves, we'd all be something else. But as professors, this is what we're doing each and every day, doing things for our students. And the second thing after being humble is to be relentless in your pursuit of doing the right thing, giving students the best possible experience, all right? And the way we can do that is we can simply ask them, how are we doing? Don't wait to the end of the semester for your course evaluations. Ask them every 7 or 10 days. How's it going? What are you liking? What should I be doing differently? How was that last lesson? Did you enjoy the game we liked? Because something that we thought was a disaster, a failed experiment, may have been the best educational experience the students ever got. Remember, your students want you to be successful. No one walks into class on the very first day in the semester and says, I hope this class stinks. I hope the professor is boring. I hope they give me lots of homework. I hope it actually sucks the marrow out of my bones. They want you to be inspirational and motivational and passionate. They want you to be so great that they get out of class on the first day and run to their friends and say, you are not going to believe how lucky I am. They're cheering for you, and sometimes we forget that because it's an us versus them mentality. No, it's a we, all right? How did I get to where I am? Started doing research, just like any other type of research project. How can I make this better? Where do I go from here? How do I make it better tomorrow than it was today? Find a mentor. Find one in your department. Find one outside your department. Find one outside of your college. Find one in the industry if you want to. Find people that can provide more ideas for you about how you can continue to make things better. Take advantage of all the resources that ASW has to offer. Go to a training workshop or a conference. I've gone to several over the years. A couple that I've been to, the National Effective Teaching Institute, or NETI, that ASW has been putting on. Project Catalyst at Bucknell University was a wonderful opportunity for me. Another one was the National Academy of Engineering's Frontiers of Engineering Conference. Amazing opportunities to learn more about what other people are doing and how you can get better. Take advantage of all the resources that Keene has to offer. The engineeringunleashed.com website. Even if you're not at a member school, there are resources available in the annual conference and educational opportunities that you can take advantage. And heaven forbid, if you can't find what you want, do it yourself. That's what we did. We wanted a conference. We're going to be able to go back and do more sandbox type work and playing with just ideas. We came up with Reimagined Engineering and had an opportunity to go back and actually say, how could we just do this better from the very earliest stages? Just remember, Rome wasn't built in a day, but they worked on it every day. Keep trying to make it better tomorrow and next week and next year, and you'll be surprised at what you can do over 10 years. Some last thanks. Deep appreciation to all my friends and colleagues in the awards committee at ASAA, my students and faculty and cohorts back at Valparaiso University, Doug Tugoff for his leadership and mentoring. Hi, Doug. My friends over at Disney, James and Jen and Tom and Stan, for encouraging me to dream. My parents for teaching me from a very early age that everything is possible and that I can do anything. My kids for reminding me that every single day. And my wife, Heather, for simply giving me the courage to believe that we can do this when we get scared. That's what I got. Thank you so much for your time. If any of this sparks any interest in you want to talk about engineering education or talking about play, send me an email. Grab me right after the session. Let me know what I can do to help. I can't wait to meet you. Thank you so much. God bless and have a great morning.
Congratulations again, Mark. As academics and those seeking continuous improvement of engineering education, an ASEE conference paper is our primary vehicle to share our work. These papers are in some ways the lifeblood of what we do and are the foundation of this annual conference. In light of that, I am humbled and honored to recognize our peers who are the authors of this year's best papers. The awards today are for the 2018 Best Overall Zone Paper, the Best Overall PIC Paper, and the Best Overall Diversity Paper. ASEE is thorough and rigorous in choosing our best paper winners. The overall best zone paper is chosen among the numerous nominated papers from the ASEE sections. For the best PIC paper, the divisions within each of ASEE's 5 PICs can nominate an outstanding paper. Each PIC chair, working with a committee, will determine the best paper from his or her own PIC. Then the 5 PIC chairs identify the best overall PIC paper. In choosing the best diversity paper, individual paper reviewers are asked to nominate manuscripts that address any aspect of diversity. A subcommittee of the ASEE Diversity Committee then chooses the best paper from those nominees. It is now my pleasure to welcome to the stage the Zone 1 Chair, Shane Rogers, to introduce the best overall zone paper.
Good morning. I'm Shane Rogers, the Zone 1 Chair, and it's my great pleasure to introduce the best overall zone paper, the title of which is Assessment of Progressive Learning of Ethics in Engineering Students Based on the Model of Domain Learning. The authors are Dr. Ivan E. Esparragosa, Dr. Shadon Cottrell-Cognac, Dr. Abdullah Konak, Dr. Gul Kramer, and Dr. Kristen Lee.
Thank you, Shane. I'm Gul Kramer from Iowa State University. Allow me to show you what we have in store for you today in our 10 minutes. The list, though, is not complete. It should have included the first phone call, our first meeting, writing the grant proposal to NSF's Division of Undergraduate Education, more. But in 10 minutes, I cannot give you details. But you know what it takes. Yes, indeed, there was a phone call. One of us, from the 4 that you're seeing on the screen, called the others and said, I'm reading about model of domain learning. It is interesting. It is including interest or motivation in student learning. It seems very logical. But at the same time, Pat Alexander, she claims that it's progressive and you can indeed measure growth in learning over time. I'm a bit skeptical about this. Should we try this for professional skill learning development? After I called on my friends and they said, I'm in. Then came this meeting at the Berks campus of Penn State University. We set out to put together our 3 guiding questions. How do we assess professional skill development in our engineering students? How do we explain differences in their learning across time? And how is it that we can develop curricula that will facilitate learning of professional skills? Given 4 people that we have in the team, we picked 4 professional skills: ethics, teamwork, global awareness, and creative problem solving. Yes, indeed, we are going to talk about ethics today. But before then, let me say a word or two about model of domain learning. This learning theory by Pat Alexander takes into account knowledge, strategic processing, and interest as the components of learning. And it is progressive. It looks at growth over time. And then it looks at interrelations of those 3 components and maps the learning into 3 different stages of acclimation, proficiency, and competency. Interest at first is external. Over time, it becomes personal, sustained. Knowledge is fragmented at first, and then the structure becomes more clear and deepens. Strategic processing is very simple at first. Application of facts. Over time, it becomes effective, it becomes deep, and applying to new domains. With this, I'm going to turn it over to my colleague, Ivan Esparragosa, to talk about ethics, which is the main part of it today.
Thank you, Gol. We decided to start with ethics because ethics is an important topic in any professional discipline, particularly in engineering, since we have a great responsibility as we build the world and we transform the world. As we know, as instructors, it's challenging to teach and it's challenging to assess ethics. There are some ethics tools that has been used. I'm just showing in the screen a couple of them. The Defined Issues Test, DIT, and DIT-2, which are focused in studying moral reasoning of students. The SEED is study curricular and co-curricular activities related to ethical development in knowledge, reasoning, and behavior. And many of us might be using rubrics as part of the ABET process or a way to assess ethics. However, none of them show the stages of learning and the process of learning ethics through the curriculum. So we were interested in learning or knowing how students evolve from personal moral values to the ethics or ethical behavior once they graduate, and which learning components contribute to the development of the ethical skills. So we decided that we should design and develop an assessment tool that allows us to capture the development of the skills through time, through the curricular, and see the relation between the different learning components. And this is how we decided to use the model of domain learning explained by Gul a few minutes ago. So we arrived to the research proposal. So the goal of this study is to determine the progression of engineering students' ethic learning as can be captured by the model of domain learning. And we have 3 basic equations. Do the learning components, interest, knowledge, and strategic processing, increases over time through the curriculum of engineering curriculum? Does the student's journey between the stages of learning, acclimation, competence, proficiency, improve along the engineering curriculum. And the last one is if there is a correlation between the interest and the other two learning components, knowledge and strategic processing. So we developed the research. We developed an instrument with 31 questions. The first 5 questions were about demographics, because we would like to distinguish the students, where are they in their learning, career. The other questions were about concepts to develop or to understand the different learning components. And they consist of concept questions, very short cases, and interest questions. The demographics, we have 1,161 students participating in the study, 951 valid surveys, and then you can see the distribution, the demographic distribution in terms of female, males, and level of students from freshman all the way to senior. And these are the results. So in the first graph, we have the results of the learning components, how interest, knowledge, and strategic processing is developed through the academic career. So from left to right, you can see from freshmen all the way to seniors. And you can see that in every single learning component, there is an increment along the time. It can be seen that in the interest, the difference is not significant, but it is significant in the other two learning components. The next graph, results, summarizing the results, is the stage of learning, how the student reach acclimation, competence, and proficiency. And as you can see also from left to right, going from freshman all the way to senior, you can see that there is always an increment in the learning. Finally, we did a study of the correlation to see if there was a strong correlation between the different components, and there was a strong correlation except for the case of the interest and the knowledge and strategic processing, which is a surprising result, but it could be based on the concept or the notion that ethics is not a technical concept and it might be the most valuable topic for engineers. So finally, we can conclude that the MDL can be used to measure the progressive learning of ethics in engineering, taking into consideration the 3 learning components, and indeed, there is a correlation, but it's not as strong as we were expecting, and you can see it also from the results that there is no significant difference in the interest between the freshmen and the senior students. Thank you very much.
Hi, my name's PK Embry. I'm the PIC 3 chair, and it's my great pleasure to be able to introduce the 2018 Best PIC paper. It comes out of PIC 3 and from the Engineering Design Graphics division. The title of the paper is Case Study of a Blind Student Learning Engineering Graphics. The author is Dr. Steve Zemke from Whitworth University. Please welcome Dr. Zemke.
Good morning. My name is Steve Zemke. I'm from Whitworth University, as you just heard. And I'm going to talk about a paper from last year, a case study of a blind student learning engineering graphics. And if you think about this, you wonder, how does this arise? Engineering graphics is probably one of the most visual aspects, and then this student was completely blind. And so here's how the case arose. We had a blind student in our mechanical engineering curriculum, and she attained to a junior standing, and this was at Gonzaga University in Spokane, Washington, and the curriculum required a graphics course. And to get the degree, you have to fulfill the requirements, and so she had to have a graphics course. And so here was the conundrum we were faced with. First off, there were the curriculum requirements. The student must have engineering graphics. On the other hand, we needed to accommodate the student's need. And so how are we going to accommodate the student's need? Because right in the middle was the CAD system, which is really like a brick wall to a blind person, because all the features that make a CAD system marvelous for sighted people, like context-specific menus or picking a point off of a model on a screen, those cannot be hard-coded into keyboard commands. And so everything that makes it powerful makes it impossible for a completely blind student. So here's what we did. We said we need to solve the actual problem, so we pushed the CAD system off to the side. Once we put it off to the side, we said engineering graphics, not CAD, is the actual requirement. Our requirement was engineering graphics. Once we had that in mind, then we thought, well, we can teach graphics if we don't have CAD stuck in the middle of it. So accommodations would be possible. Now, how did we go about teaching the graphics? Well, here's what we did. We had a targeted summer course. You can probably read that more as one-on-one tutoring. I met with the student twice a week, Tuesdays and Thursdays from 8 till 10 in the morning. So it was over 12 sessions, so 6 weeks, half the summer, 2-hour sessions. And here was a key component of it. We adjusted the content and the credit based on the progress. I had no idea starting how well the student would progress, right? So I could adjust the credit. And we said, what's the lower bound on the credit in case this just becomes untenable? And so that's how we got it. And of course, we used assistive technologies to do this. So here were our course goals. Required. By the end of the course, the student must be able to read an orthographic projection. So here's a front, a right, a top view. Can you read it and pull information out of it? The other requirement on this was, can you sketch one? You must be able to take an object, say this little controller, put it in your hand, feel it for a bit, and draw me a front view, a top view, and a right view. Okay, basic communication skills is what we were after. What we wanted, though, was more, right? Isn't that what Americans want? I think that's people. At any rate, what we really wanted was, can the student learn to read or sketch an isometric? So can we work in perspective views as well? Because those would be most helpful working later in the curriculum with teammates on design projects. And what was truly desired, we wanted the moon, of course, right, is can you do this holistically? And by this, I mean, my CAD system can draw an isometric from the model information, right? And it does it all algorithmically. The CAD system has no knowledge of what's going on. But could the student take a part, feel the part, get it into her head, and then say, the front view should be like this. So that would be truly great if we got there. So here's the assistive technology that we used. First was a Braille sketch pad. You can't really see from the photograph of it. It's a polyurethane bed, so a compliant bed. You stretch a piece of Mylar over the top and clip it down, run a quill over it. That stretches the Mylar and it pooches up, so you can then feel what's been scored on it. And it also turns it white, so I could see, which was nice. I never did learn to read with my fingers like that. The other piece was the swell paper, which is a simple paper. You mark on it in a black pencil or run it through a photocopier. Then you post-process it through some heat lights, and any place that's black swells up and gives you this tactile ridge that you can feel. So those were the assistive technologies that we used. Okay, stepping into it, here's what we did. We started with printed models that were in that she could manipulate. And so here's an example of an orthographic sketch that she drew, a triangular front face, and then the true size, true position, true size, true shape view up and to the right on that one of the angled face. And notice all the features are in there correctly. For those of you who don't do graphics, there's also all the construction geometry left over that you can't erase. So you kind of have to get used to looking to the construction line. So the projection lines and the rotation line there. So every feature is correct in that, maybe not quite to scale. That scale was very difficult. Okay, we also did the traditional thing from my mother's graphics book from the 1940s, which is I want you to sketch the missing views. So notice on this we have a swell paper, B size, of a top and a right view and a cutout. You stick it over your Braille sketch pad and sketch into the center view there. And also up in the upper right, you notice there's an isometric view of the part, and that was used to disambiguate anything that was missing in between the right and the top views. Okay, we also did an exercise identifying corresponding faces. So here's an orthographic projections and an isometric of the same item. And I could say, look, see that feel that chamfered face down in the corner there? Can you identify those edges in the orthographic projection? So, and indeed she could. Now we did step into perspective views, and here's how we did it. We started with a cube, so imagine this little controller here. From the front view is going to look like a rectangle, the right view is going to look like a rectangle, the top view is going to look like a rectangle, right? So a cube starts by a square, and indeed we started with a cube, and we'd ray trace from our nose to the cube, the corners, okay? So we were well up to that. Then we said, well, what happens if you rotate the center view over 45 degrees? Now what does the side view look like? And of course, now you've got receding views on it, right? And we work through that, and you do one more rotation of the center view and tip it back, and now you've got an isometric. And so that's how we got into isometrics. Let me show you a view of an isometric that she made. This was a printed part, so she had it to manipulate. And it's an L-shaped part with a chamfer down in the two front lower corners and a hole through it, as you see. And what's interesting is if you look close, I'm not sure if you can see it in the back, but line annotated 4C and 4D, those are straight in line with each other. Do you see that? They're collinear. That is correct graphically. And I asked her, can you tell the difference? And she says, and this is her quote, the chamfer line doesn't look up and down, it's on that flat surface there, but looks like it's at an angle because of how the rest of the part is. At that point, I thought I'd won the lottery. Okay, she was doing really well. And let's see. Let me just mention one more thing since I got a minute here. One really interesting thing is I drew an XYZ axis, and she said, oh my gosh, that's what that means. She'd gone through all this calculus and three-dimensional calculus and had never figured out what a three-dimensional axis actually meant. Okay, in the paper, but not in the talk, there's a nice literature review of the cognitive literature of visual processing, mental imagery processing, appropriate laws, and some other things. There's a comparison of student abilities to the cognitive literature, so it's much more in detail. Finally, the student could fluently draw and read, and there was evidence of all the things we were looking for. And so thank you very much. And I'd just like to say, the book is better than the movie, right? That paper is better than this talk. Thank you.
Good morning. I'm Rebecca Bates, Chair of the ASCE Committee on Diversity, Equity, and Inclusion. It is my pleasure to introduce the 2018 Best Diversity Conference paper. The title of the paper is Effects of Research and Internship Experiences on Engineering Task Self-Efficacy on Engineering Students Through an Intersectional Lens. The authors, and the first author is presenting today, Abisala Correta-Cusimo from Stanford University, and her co-authors are Marissa Elena Thompson of Stanford, Dr. Sarah Atwood of Elizabethtown College, and Dr. Sherry Shepard of Stanford. Congratulations.
Good morning, everyone. So I wanted to start by giving you an overview of who I am. And this is how I started the presentation last year as well. So I'm hoping you get a sense of the different things that color my perception, influence and shape how I interact with the world and how I show up. So I'm here to talk to you about the effects of intersectionality, research, and internship experiences on engineering task self-efficacy. And so how I started this off last year was by going into a deep dive of what multiple linear regression was and how to take interaction terms. So I started here, or I ended up here. And so what I showed was the importance of taking interaction terms, how it turns out that it actually influences the significance level that we see, and why it's important to do this as opposed to doing controls, but don't worry, I'm not doing that today. Instead, I want to tell you a story and I want to paint a picture of how I got into this research and why I thought it was so important. So, spoiler alert for the paper, this presentation is actually going to start with the last sentence of the paper. It's the last sentence in the abstract and the last sentence in the future work section, and it goes like this. This work seeks to challenge the bias towards monolithic interpretations of the URM, the underrepresented racial or ethnic minority, or female engineering student, and encourage intersectional perspectives when analyzing data. And so in order to really understand what I meant by this sentence, I have to tell you one more thing about me. And that's that I love Oprah. Love Oprah. My parents are in the audience, they can attest this, so can a couple friends. And the reason why I finally figured out why I've been so transfixed on Oprah's show and on Oprah for so long, and it's because she's so good at asking questions. And what I've come to realize is that when we can ask better questions, when we can ask challenging questions and good questions, we can actually start to change the world. Let me give you an example and explain how this is actually working. So for example, this is my slide representing physics. And Thomas Kuhn wrote a book called The Structure of Scientific Revolutions. And in this book, he explains in a five-phase process how the world has changed through different fields and through different disciplines. For this example, I think about Galilean physics, Newtonian physics, and then thinking about Einstein. In a matter of different generations and decades, we've seen this field of physics change dramatically. What we thought we knew, what we thought was true, and what we thought was possible all flipped on its head when we started asking different questions and brought different researchers into a discipline. So now I want to give an example of an engineering classroom. And we all know that this is a stock photo because everyone is smiling. But moving forward, let's just pretend that we're in an engineering classroom, for example. And so what these researchers did in this example was that they wanted to ask a different question. They set out to find out what makes an engineer innovative. And so they looked at some of George Koo's top 10 high-impact practices, and for the purpose of this talk, I'm going to focus particularly on research and internship experiences. And so here's what they found. So looking at I want to focus on two demographics that they pulled out in the paper, and that will be gender and race. And race was categorized as underrepresented racial and ethnic minority status. So for gender, they found that women have less confidence than men in their ability to perform engineering tasks. Makes sense. Then they found for race that underrepresented minority students had similar levels of confidence to non-underrepresented minority students. Okay, this is also very interesting. But it made me wonder, how does this actually look in practice? So let's just take the black female engineering student, and we're going to take the white male engineering student and just focus on those two, looking at the data that we just saw. So that would mean that as a female engineering student, that student most likely will have less confidence than her white male counterpart, classmate. But also as a black student, it would mean that she has similar levels of confidence to her white male classmate. And so that made me wonder, what do these results actually mean for someone like me? And so I took a deep dive into the data, and I decided to break up the data by non-underrepresented minority status as well as gender. I couldn't go further into different races specifically because of the power you can see in the lower half of in the middle section of the lower half, that the actual numbers for the underrepresented minority students was very small, so we had to lump them. But for the sake of doing this presentation, I'm just going to focus on a black female engineering student and a white male engineering student because underrepresented racial and ethnic minority is a mouthful. Bear with me. Okay. So why was it important to look at this intersectionally? Well, I think Audre Lorde said it best in her quote. There's no such thing as a single issue struggle because we do not live single issue lives. And if that's the case, that means that we need to understand how these different identities are coming together to inform these experiences. So this is what I found. So looking at that black female engineering student and the white male engineering student, when you compare those students, when you compare a group of students that had an internship versus students that didn't have an internship, this is what you saw happen with their confidence in engineering abilities. The black female student actually had a much larger difference between having an internship and not having an internship experience versus the white male student. But of course, I have to complicate the picture a little bit because that's not actually how it looked. What was really happening was that their baselines were completely different. So the black female engineering student was actually starting much further behind the white male engineering student. And when you gave her an internship, which is supposed to be a very high impact engineering practice to engage in an undergrad, you saw that she actually got to the level of where the white male engineering student was at baseline. So this very high impact practice actually was having an enormous impact on her experience and her confidence, her ability to complete engineering tasks, yet she was also still remaining behind where the white male student was, would then proceed to. So I wondered what could be contributing to this difference in baseline confidence. And I just did a quick Google search of what an engineer was in 2019. Funny. So what I noticed were a few really interesting things. So first, out of the first top 18 pictures that were selected, or that I took from the screenshot, I saw that 6 of them had women in them. So that would give us about a 33% ratio of women in engineering, just looking at the top 18 results, which is more than the national average and is interesting. But also I noticed all of the women in the picture were white. Then another thing I noticed was that they also had a few black engineers also in the pictures, but all of them happened to be in the background. So 4 of the pictures out of the 18 gave us about 11%, which is a little bit less than the national average, but it was only the top 18 results on Google, so kind of let it slide. But what I did think was interesting was all the black engineers were men. And so this brought me to a book that I saw as I was looking up Kimberly Crenshaw, famously known as the scholar who coined the term intersectionality. And what I saw was this book called All the Women Are White, All the Blacks Are Men, But Some of Us Are Brave. And it made me think, how do we avoid people like me constantly slipping through the cracks? If it happens that all the women we're talking about are white women and all of the underrepresented and racial ethnic minority people that we're comparing to one another are men and male engineers that we're comparing to one another, what happens to people like me who also want to act on that data or act on those results and understand where we fall in the picture? And I thought of this really great quote, which is that excellent research doesn't systematically leave out particular variables. So what can we do? I think we need to update our script. We need to start asking, here's what we did, here's why we did it, and here's what would take this analysis to the next level so that even if you don't have enough power, if you don't have enough in your sample, that we can have somebody else carry that project forward and actually be able to figure out what is happening to these other groups that may not see themselves represented in our data. And so I have a vision for the future of research. I know it's a grand vision, I hope. And that's that I want to see research being more accessible. So getting to the hands of people who we're hoping to impact, as opposed to just staying in these rooms or staying in these conferences. What I'm also hoping to see is more accountable researchers, so that someone doesn't have to walk into a situation, open an engineering education research paper or any field research paper and not be able to see themselves represented, or at least be able to understand why it was that they couldn't have their stories told too. And what I also want to see are actionable recommendations. So even after looking at what happens between a female engineering student and an underrepresented racial and ethnic minority student, what can they actually do to improve their confidence, or what are some practices that they can engage in, but giving people tangible tools so that they can act on this research. And I want to go back to what I said earlier about Oprah and what I fundamentally believe, and that's when we ask new questions, the world actually begins to change. And I fundamentally believe that we have seen tremendous things happen in this conference and also in spaces like these when scholars and different scholars and scholars with various identities come together and they question and challenge the status quo. And so I want to thank you all for your attention, and again, in true fashion of me, leave you with myself. Thank you.
I don't know about you, but I think the future's in pretty good hands. Thank you, Basola, for your talk. And thanks to Gul and Stephen and Ivan for their talks. Let's give another warm round of applause for our award winners this year. I've always wanted to say this, and now we'll have a word from our sponsor, the University of Maryland, College Park.
They say home is where the heart is. But what if home is where innovation comes to life? This home, our home, was built by those with a daring vision for the future. Those pioneers of innovation accepted challenge and conjured inspiration to lay the foundation of the A. James Clark School of Engineering. Our pillars are strong. They stand on the shoulders of engineers who tackled the greatest obstacles of their time. Our ceilings are limitless. Our doors are always open. Our framework is cast with the heat of discovery. When there were storms, imagination and discovery became the hammer and nails that bonded us forever. We are never satisfied with the words good enough or just fine. Instead, we seek to make a lasting impact on humanity. So please, come on in. You have an open invitation to join us in the engineering process as we sculpt, craft, weld, devise, and architect the next 125 years of engineering impact.
Thank you, University of Maryland. It is now my pleasure to introduce our keynote speaker this morning, SaLisa Berrien. SaLisa Berrien is founder and CEO of CIO Energy, following a long and diverse career in the energy space, working for organizations such as PPL, PECO Energy, and Con Edison. She and COI Energy practice the platinum rule, do unto your customer as you would have them do unto you. SaLisa is the founder and chair of Strive, Inc., a charitable organization focused on STEM leadership development and training for students in 3rd through 12th grades. In 2013, she established COI Ladder Institute to focus on developing leadership and empowerment services to millennials and women. SaLisa has also established several scholarship funds for high school and college students. She holds a degree in mechanical engineering from the University of Pittsburgh and an executive MBA from St. Joseph's University. She's been a guest speaker at various conferences and events, including SXSW, NSBE, the University of Pittsburgh, Florida's Women in Energy Leadership Forum, and Morgan Stanley Sustainable Futures Summit. One of SaLisa's core values is philanthropy. I am stuttering this morning, I'm so sorry. She believes that to whom much is given, much is required. Her mission in life is to positively impact the space she occupies by leaving it better off than when she found it. Please join me in welcoming SaLisa Berrien to the stage.
Greek tragedy. Imagine your first day entering your senior year in your atomic physics class, and your professor tells you that you're a Greek tragedy waiting to happen. He then went on to talk about how people that look like you don't belong in his class. And whenever I rose my hand to ask a question or to answer, he wouldn't call on me. But he made it his business to make sure that I was never recognized. So much so that he failed me on every quiz and every test that I took. My reaction was initially introspective. I was like, what's wrong with me? What did I do to deserve this? Like, what's really going on? I typically am able to draw people to me, and I was unable to reach this professor. So quickly, I got into gear and recognized that I deserved a seat in that room. I deserved to take my final physics course at my alma mater and pass it. So I went to my mentor, Dr. Carl H. Lewis at the University of Pittsburgh, and I said, I don't know what's going on in this classroom. My first week, the professor tells me I'm a Greek tragedy waiting to happen, and he's failed me on every test and quiz. Now, my study group, which no one looks like me in my study group, we've had similar answers on the test. So I didn't understand how I failed it, but they passed. So my mentor says, SaLisa, don't worry about it. We'll take care of this. They had to elevate this to the provost's office to get an independent person to review all my tests and quizzes to see if, in fact, I failed every single one. It turns out I failed none. And the professor had to go back and change all those grades. I start off with this story because it's so important to understand the value that is placed in an educator. Each of you have a critical role to play, and you could speak life or death in a situation. So the young lady from Stanford that just gave her presentation, it really resonated with me because I'm that minority that they felt slipped through the cracks. But if I didn't have the opportunity to be a part of the Pitt Engineering Impact Program that Dr. Carl Lewis founded, I wouldn't have had the confidence to go to someone and say, what should I do? I can't reach this professor. And he's treating me really bad, and he's calling me a Greek tragedy. I never had anyone say something like that to me. So the SaLisa Berrien that I am, I'm a traditional engineer. The mechanical engineer I am, I'm an introvert. And so I wouldn't have normally went and asked anyone to help me. I would have just accepted as that's my demise, and I would have failed the course, and it was my last semester before graduating with my engineering degree. But the Engineering Impact Program gave me that confidence. They told us that you belong here. They told us that you can accomplish anything if you put your mind to it. They told us it doesn't matter where you started. It just matters where you finish. They told us that they will give us all of the wraparound services that we needed to be successful. They didn't only tell us, they did it. They walked every step of the way with us, letting us know that we are valid, we earned a spot in the seats at the University of Pittsburgh, and we will achieve our goals as long as we keep our head on straight and stay focused. I call this my circle of influence. My circle of influence is what led me to where I am today. And it started with a leader that had the audacity to start a minority engineering program at the University of Pittsburgh because he recognized there wasn't enough of us there. And I remember when I first showed up on the campus, and literally through my 4 years of college, I didn't like him. I felt he was too hard. He came from Barbados, so I didn't think he understood the African-American experience. And it was like, you could do this, you do that, no excuses. I'm like, who is this dude? Like, why is he talking to us like that? He doesn't know my story. And what I recognized is he was on a mission. And his mission was to ensure that he produced successful, underrepresented minorities and all other engineers. And he did that. So he didn't care that we didn't like him. I didn't know that was a part of the whole MO because I'm like, who is this dude? And The day I graduated with my mechanical engineering degree in 4 years, I was the first person that gave the minority engineering program a plaque to award them because they saw something in me I didn't see in myself. So let me tell you a little bit about myself. I'm from Allentown, Pennsylvania. The university did not recruit in Allentown, Pennsylvania. I was hijacked by the Me Too movement at the end of my 8th grade year, before there was even the term Me Too. That resulted in me having a child in 9th grade. I graduated from high school on time with honor roll. I went to the University of Pittsburgh and got into a foundational program not like Impact, it was Impact, that gave me what I needed. I'm going to keep referencing back to the young lady from Stanford, because when she talks about where you start and the confidence that women and African American women have, everyone had a head start on me. I didn't come from a family that anyone went to college. I'm the first college graduate. 5 children in my family. I'm the 4th child, the first one to graduate from high school. The odds were all against me. I wasn't supposed to, number one, graduate from high school because I had a baby in 9th grade. So I sure enough wasn't supposed to graduate from high school on time with honors, taking a baby through high school with me. And then to go on to one of the top universities, giving a shout out to my University of Pittsburgh, with a mechanical engineering program 5 hours away from home with my baby. And I graduate in 4 years. I gotta tell you, the circle of influence means a whole lot. It started from a teacher when I was in 11th grade, noticing me after school because I chose to stay after school until as long as I could, and then go to the daycare and pick up my daughter. And one day, she just happened to say, it was 30 minutes of her time, "What do you want to be when you get older?" And I said, "I want to be an attorney or a radio broadcaster. I wanted to be able to use my voice to help people like me." And she said, "SaLisa, there's enough attorneys in the world." She's like, "But you're good at math and science. Why don't you be an engineer?" I said, "I don't want to work on cars, and I don't want to fix trains. So I don't want to be an engineer. That's like not cool." And she says, "That's not what engineers do." Mind you, this is 11th grade. And she says, "Let me tell you what engineers do. They solve problems." I didn't understand that concept. And so she went on to say, "I'm going to get you enrolled in a shadowing program so you can shadow the city engineer." Circle of influence. People that believe in you more than you believe in yourself. She didn't only say what an engineer was, she showed me what an engineer was. So I ended up shadowing the city engineer, city of Allentown. Got to understand civil engineering. The following year, the following summer, before I went to college, they allowed me to intern as an engineer for the city, doing street light design and things like that. But she didn't stop there. She looked at and said, "There's a bioengineering course being taught at Lehigh University. It's a summer program for gifted students. You should go." Okay, so end of 8th grade, I become pregnant. I don't know what's happening to me. I totally go off the grid. My grades dramatically dropped from being an honor student in middle school to like almost failing in 9th grade. 10th grade, I was picking it up a little bit, but not so much. I was still mediocre. So by 11th grade, for her to say, You're going to go into a gifted program at Lehigh University. Imposter syndrome, I don't qualify, right? I get in. I'm at Lehigh University with the brightest minds from across the world that came in for this bioengineering program for 6 weeks. And I successfully graduate from that. And that opened up my whole world of what engineering was all about. I end up going on and I applied to the University of Pittsburgh. I get in. I said, I got to get as far away from home as possible because I didn't have people in my circle there that believed in me other than that teacher. So let me go somewhere far. And people are like, how are you going to do that? You have a baby. I was like, I got to figure it out. I show up to the university campus with this 3-year-old at the time, and I remember Dr. Lewis's face. Whoa, no one knew I had a child. They were like, where is she going with this baby? I don't have any other option. I have to bring my baby with me. It's my baby. And Dr. Lewis is like, no, you can't do that. So my dad is there trying to figure out, like, what am I going to do? And he's like, that baby has to go home. So I had to figure out something in the 11th hour what I was going to do with the baby because they were like, you're staying in a dorm. Baby can't stay there. That shows you how clueless I was, right? Like, I'm this kid. I really didn't understand what was going on. And it got me to a level to say, I got to make a sacrifice. And one thing Dr. Lewis says, if you sacrifice now, your daughter will be set up for the rest of her life. I didn't understand how I sacrificed without my daughter there because from the time I had her, I had to take care of her. No one helped me. My mom told me, if you have this baby, you got to take care of it by yourself. So in 9th grade, I had to be a parent. I had to do all the things that parents did, plus show up to school every day and try to focus on academics. So yes, I started behind. And I didn't have a head start. But what Dr. Lewis taught us was changing your mindset. And when you change your mindset, you change your trajectory. And him drilling in, you can be anything you want to be, made me realize, wow, I can. So when I look at business and how I've applied engineering to business, I've gone in there with the mindset that you can solve anything. If there's a problem, it can be solved. So out of college, I went and I worked for PPL, it's an electric utility, investor-owned utility, in their marketing and sales organization. We didn't have really marketing and sales. It was regulation, a monopoly. We didn't have customers. They were ratepayers, but we were making believe we had that, right? So I was this marketing engineer, and my responsibility was to go into industrial and commercial operations, look at their processes, make recommendations on how they can eliminate bottlenecks, and improve their bottom line. So here's this little girl from the University of Pittsburgh with my mechanical engineering degree, and I'm walking into all this big business trying to tell them how to solve their problems. And I was faced with a lot of resistance. Over the phone, people thought, oh, wow, this girl is really sharp. And then when I got there in person, they took a step back because they didn't know I was black. So the one guy over the phone was saying, hey, are you blonde? And I'm like, no. He's like, are you a brunette? I'm like, yes. He's like, so you have brown eyes? I'm like, yes, I do. So when I showed up in his office to be that person to solve his problems, first he was embarrassed because he didn't think I was black. But then he was like, I don't think she can really solve my problems. I went on to be very successful at PP&L. I sold the first electric vehicle in the Northeast region. It was called the G-Van, if anyone remembers that. It only went 60 miles, and then you had to plug it in. But I sold the first one there. I received excellence awards in customer satisfaction because I understood that even though people didn't believe that I deserved the right to be there, I gave them that respect that they deserved. And my customers began to really receive me and recognize that, whoa, she can solve these problems. And not only that, she's honest. If she can't solve something, she'll tell you. And she, by the way, would offer a solution that might have been her competitors, but she would tell them the honest truth. So over my career, I had customers, wherever I went, they would follow me, except under the regulation piece. So if you're a utility, it's a monopoly, right? So this is when I fast forward into the deregulated markets, and customers are like, SaLisa's an honest person. She typically solves my problems. If she can't, she will tell me where I can go to get that solution. And so with that really helped me on my corporate side when I worked in big companies. So we'll fast forward to 2006. I went to my first startup. And in that startup, it was totally amazing. I don't know how many people have worked in a startup, but going from big corporate into a startup, and it was Boston clean tech company, and I found like this new world. It was like, wow, you have this blank canvas and you can paint it any color you want. You wear 10,000 hats. It really fit me being an engineer because I could just like solve all these problems, and I did that. I helped lead my company, it was a smart grid company, to being the #1 demand response company in the world. And it was this little girl from a public-private university. Most of my colleagues came from the Ivies. So when you research a lot of the startups, it's like you're focused on getting Ivies. If you get the Ivies, you're really going to be successful. My colleagues could not compare to me. And not boasting, just kind of just telling what the facts were. They were like, how is she getting all these customers? How is she growing this marketplace? So the president of the company decided to take me to Europe to grow the market in Europe as well because of the work that I did in the United States. I gotta tell you that all of that came with my engineering degree. My engineering degree taught me that you can solve anything. And so when I got out into the startup space, it was a little bit different from what I was used to in the corporate world, but what I found was there were problems to be solved, and you figure out how to solve them. People were like sales. I started interacting with traditional salespeople. As an engineer, we're not salespeople, we solve problems. So if we go in there with that mindset, we know that the customer typically is gonna sign on to what you're doing because you're not trying to sell them a widget, you're trying to give a solution to what their problem is. And so what my colleagues didn't know that came from the Ivies, because they came out and they had the Ivy degree, and I love my Ivies, guys, I totally love my Ivies. But what they didn't know is that it wasn't about selling that widget. It was about developing a relationship. And you develop that relationship and you understand who your customer is first before you try to sell something. So my leadership says, SaLisa, our business model is to sell singles, doubles, and triples. Once in a while, a home run. But why do you keep going after only home runs? That's not our business model. You have to stop doing that. It's like, whoa, I thought that was a good thing. Well, the reason why it wasn't a good thing is because it took longer to develop those home runs. So you had to cultivate relationships over a longer period of time. So what I ended up doing, I did what he told me. He told me to do the singles, doubles, and triples. I did that, but I still on the side, I continue to cultivate those relationships. After my first year at the company, I exceeded my annual goal in August. The following year, I exceeded my annual goal the first week in April. People wanted to know what was SaLisa doing and what was different. And as an engineer, I gotta tell you, we all have that in us. We know how to solve problems, and how we connect business to engineering is make sure you put your customer first. If you put your customer first and you focus on delighting them at every level of engagement, you're always gonna win. So keep them at the center. And so when I started COI Energy 3 years ago, that was my total focus. I saw there was a mismatch. Electric utilities were looking to solve a problem with the grid. And one of their biggest challenges was they could not see what was behind the meter. So they couldn't see what was inside businesses, what kind of equipment they were adding on. And businesses, they didn't have transparency to actually understand what the value of their assets behind the meter were. So I was like, hey, let's start an energy on demand marketplace where businesses and utilities can buy, sell, trade, and gift energy anytime and anywhere. People are like, oh, how'd you come up with that? Well, I worked at a utility. I recognized what their problem was. And I worked on the smart grid side, and I noticed what was happening with the business customers, where they were selling their assets back, their flexibility in order to support the electric grid, but they weren't getting the full value of that. So third parties were taking 50% of their revenue. And I was like, oh, no, we can do this. You can keep all your revenue. You're doing all the work. And so it was a business model that's totally different and kind of changed the game. And here we are today with COI Energy being the first energy on demand marketplace where Morgan Stanley invested in my company, where SAP is one of my strategic partners, and I am the only startup that they've partnered with on a non-wires alternative. So what I say to everyone here is one size doesn't fit all. When you have a person show up in your classroom and they look a little bit different. They have a 3-year-old child. They had an average GPA because the honors, even when you look at the last 2 years I got honor roll, those other 2 years it still brought me to an average GPA. I had low SAT scores, and I didn't have a network because your network is really what gives you that exposure. Would you call that person a Greek tragedy? Or would you take on the challenge to ensure that she had the necessary tools in order to be successful? We have to rethink our paradigm. We have to rethink what engineering is all about. We got to rethink the type of people because we know the world is changing and they need all of us. All of us contribute to the problem. So I say, the future of engineering is in your hands. My ask to everyone here today is that you rethink the future of engineering. Help your students build a network. And if you have mentors, if you're a mentor or a coach or a sponsor, add another one, add another mentee to your portfolio. Help someone. Because we all need help. And as you can see, the statistics are showing venture capital, so I'm raising capital for my company right now. So I'm living in New York, but I'm headquartered here in Tampa. So people are like, oh, you just flew in from New York. Yeah, that's, I'm living there right now. But if you look at the statistics, 2% of venture capital goes to women-led companies. 0.0006 go to black female-led company. Yes, I said 0.0006. And so if you can be a mentor, if you can be a coach, if you can be a sponsor, you will increase the circle of influence for these women, for these men, for boys and girls, and we can all imagine the effect that that will have as we charge up for the next 125 years of ASEE. Have the audacity to make a difference. Thank you.
It's hard to see them standing up for you out there.
Thank you.
He wants to get our picture. Wow, what a moving story. So I'm going to borrow from Abisola, who called us to action when she talked, and I'm going to marry that with what SaLisa said to us to be more supportive, but to rethink our paradigms, to rethink our future, and to rethink what engineering looks like. That was a bold talk to come before an audience like this that you don't know and share that much. thank you so very much for coming this morning and for sharing your story. And I think many times when we get to this level, all of us in the room, we forget sometimes our own struggles, or we don't share and embrace those. And I think that through sharing and embracing our own struggles, we provide a vehicle for those who may be in the same place but don't often know that. So again, thank you for such a wonderful message this morning. You know, looking out at all these faces that I can sometimes barely see because of the lights, I realize that I can see ASEE members almost anywhere I go.
Thanks again to all of our ASE members and their ladies and gentlemen, look at this. Former ASE President Louis Martin Vega and his wonderful wife Maggie. You run into ASE members all over the world. Hope you guys have a very nice visit. Thanks a lot, everybody.
It's great. Take care.
So we all know Louis, and Louis would love to be here, but he and Maggie are in Puerto Rico this week attending to Maggie's parents. So thank you again to our speakers this morning, our esteemed colleagues who presented their papers, and I would invite you to join us now for the Focus on Exhibits lunch in the exhibit hall. Thank you very much for coming.
Everything we use in our lives today began as an idea. With years of work, research, planning, and execution, these ideas were engineered into inventions that change lives. USF is engineering lives for the better, with constant teaching and testing in a pursuit of innovation. We have created solutions that change lives forever. Not just here, but in places all across the world. We are taking the next step forward, understanding that engineering isn't learned in a textbook. With a passion for constantly improving and innovating, our students grow through experience. USF engineers are more than just engineers. They're engineering lives for the better.